Example problem 1. A cyclist rides her bike 50 meters due east and then turns a corner and rides 75 meters due north. So in topic number 1, in example number 1, we have an individual that goes two different directions. One's east and then one is north. So we use the compass rose to orient ourselves in the direction that they're moving. So we end up, if I was going to sketch this diagram, we end up sketching a right angle triangle. Now on your sheet it says, one side it says make a scale diagram method or draw a scale diagram. For our problems we are just going to sketch the diagram, and we're not going to solve things through a scale diagram because the reality is we never really do that, but the sketch itself helps you figure out what direction they end up going and gives you a good ballpark if you're doing your question correctly or not. So in this case we have an individual that moves 50 meters east, then we have them 75 meters north. So again, that creates a right angle triangle, and for every two-dimensional motion question you're going to end up having a right angle triangle. So you're going to be able to use Pythagorean theorem and also trigonometry to figure out various components of the triangle depending on what the question's asking. The other thing you'll notice on this diagram is the displacement, and it is just what's referred to as the resultant displacement. So we have a capital R, and that subscript R just means that we're finding displacement. It's the result. It's the result of two vectors working together, or the sum of the vectors. And that's something that you want to keep in mind for all of the questions. So resultant is looking at the sum of vectors. Now that makes sense because we're really looking at two different directions. We're looking at the sum of those two different directions. Where did they end up? Vectors is always related to direction, magnitude and direction. So when we look at this question, we can use Pythagorean theorem to solve it. So we can write c squared equals a squared plus b squared. We're going to change our c squared to what we're actually trying to find, and we're trying to find our resultant displacement. And so we have 50.0 squared plus 75.0 squared, and you do that calculation and you're going to end up with a resultant displacement of 90.14 meters. Now that's an incomplete answer for two reasons. First one, there is the number that's not rounded to the correct number of significant digits, which in this case would be 3, and we're missing a very important component, which is the direction. Now because this is two-dimensional, we're going to have a direction with an angle. So we can use SOHCAHTOA to figure out our angle. Now remember, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we can use, to figure out the angle, I'm going to use tan. Now tan's going to be opposite over adjacent, because I'm going to use this as my reference point because that is my starting point. Started at 50, I moved east, and then I moved north. So this is my reference point. So I always start from my reference point, which is another good reason why you'd want to sketch a diagram so you have a good understanding of what angle you're actually trying to find. So in this case, because I'm looking at opposite over adjacent, then I can do tan to the -1 equals 75.0 divided by 50.0. I should have a little theta sign in there. And then my angle, that's going to come to 1.5. I'm doing the inverse function of that. That's what this is referring to. And that is then going to give me 56 degrees. Now it's going to be a bunch of decimals, but for our purposes we're always just going to round it to the nearest whole number. And so now we have to put this 56 degrees in context. So that means that we traveled east and then went 56 degrees north. So my final answer now is going to be the resultant displacement equals 90.1 meters east, 56 degrees north. And then that would be my final answer of my question. Solving the number through Pythagorean theorem, and then solving the angle through trig.